Good morning, everyone, and welcome to today's class. Everyone can see me? Everything is there on your screen? Yes or no?
Yes, sir.
Okay, I think we were discussing expansion, and I think we should be able to wrap up this thing today itself. We had seen one example or one case where you can use thermal expansion, and that case was to find out the thermal stress. Now that was case number one. In case number two, or use number two, the sorts of question that you can have is based on this particular topic: variation of time period of pendulum clocks. You must have heard about pendulum clocks, and you must be knowing the time period of a pendulum clock. Yes or no? Time period is 2 pi root over L by G.
Yes.
You all know this?
Yes, sir.
Okay. Do you also know something known as a seconds pendulum? Have you heard about seconds pendulum?
Yes, sir.
What do you know about seconds pendulum? Just tell me, fatafat.
The second pendulum time period is 2 seconds.
Yes, time period is 2 seconds. So
And
this is what that is explained here. From one
1
extreme
meter.
to the other extreme, it takes 1 second. From the other extreme to the next extreme, it takes 1 second. So the time period is 2 seconds. Normally, that is how pendulum clock works. Now, the time period of a pendulum clock is 2 pi root over L by G. Now, it is calibrated at a particular temperature theta naught, and therefore it is written as L naught. Now, it will only give correct time at that temperature on which it is calibrated, because the longer the pendulum, the more is the length. And as temperature changes, the length of this pendulum will change. If the length of this pendulum changes, then the time period of this pendulum will change. Very obvious. At any different time, at any different temperature theta, the time period becomes 2 pi root over L by G, where L is the length at that particular temperature, right? So these two time periods are not same. If I find out the new time period divided by the old time period ratio, and if I apply, what do I say, all this binomial expansion and everything, I'm not going to get into that binomial expansion. What I'm more concerned about is this formula that I get, and it's a very important formula that you must remember. This can come as a question in error, measurement, percentage error in the measurement of temperature or time period or something of that nature. Do you understand what is meant by this T dash minus T divided by T?
Change in time.
Change in the time period divided by the original time period. So this is basically time gained or time lost per second. Do you understand this word? Time gained or time lost per second. And in simple terms, you can just write in this form: time gained or time lost in a period of t seconds. This is time gained or time lost, time gained or time lost per second. Do you understand this? Time gained or time lost per second is half into alpha into delta theta, where delta theta stands for the change in the temperature. If I have to find out how much time it has lost in 1 hour, I will multiply this term by 3600. Do we understand this?
Yes, sir. Yes.
So remember, the first formula is time gained or time lost per second. If I have to find out how much time it has gained or lost in t seconds, I just multiply it by t. Remember, it is t seconds. Okay, now when does it go fast and when does it go slow?
temperature increases, clock runs slow.
When temperature increases, the clock runs slow and it loses time. When temperature decreases, the clock runs faster and it gains time. So you are aware of this?
Yes, sir.
You are aware of this? You have noted this down? Then you can just do a simple problem and log this point here, and now itself this question has come once, I think twice it has come in the previous JE. So the question goes like this. If you know the concept behind it, the question is pretty damn simple. This is how the questions are framed. A pendulum clock. Again, remember, you get only one chance to read a question. A pendulum clock consists of an iron rod, does not matter, connected to a small heavy block. It is designed to keep correct time at 20 degrees Celsius. So it is calibrated at 20 degrees Celsius. How fast or slow will it go in 24 hours at 40 degrees Celsius? Will it go fast or will it go slow?
Slow, sir.
Slow, because the temperature has increased. Alpha for the iron rod or iron is given. You just have to find out how much time it will gain in a period of 24 hours. So how do you do it? You just apply the concept that you have read just now. The time gained or time lost in a period of 24 hours is half into alpha into delta theta, that is per second, multiplied by the number of seconds in a day. I think it is 86,400. Just multiply it. Multiply it by the change in temperature. Change in temperature is 20 degrees. 40 minus 20 is 20. And you have 1.04 seconds as your answer. Is it clear to everyone? Everyone understands this question?
Yes, sir.
Have you done this question already? See, the only way you can do such questions, and such questions normally come in JEE Mains at least, may not be in JEE Advanced. In JEE Advanced, it might come in the form of a percentage gain or percentage loss. What is the percentage gain in time period or percentage loss in time period? You must understand that they mean the same thing. I mean, it's not different. You must know the concept that per second how much it has lost, so you can from there you can find out the percentage as well. These questions come, the only way you can do them is if you know how it has to be done. Okay, shall we move ahead?
Yes, sir.
Okay, that is the second use of thermal expansion that we have seen. First was thermal stress, the second is time gain or time lost in a pendulum clock. Do you know of any other uses of thermal expansion? Remember, we are dealing with thermal expansion, or I should say linear expansion of solids. From there we'll go to areal expansion and then volume expansion and then further ahead. Do you know of any other use of thermal expansion in solids? Where you can use this? Any idea? The third use?
Thermal
Okay.
expansion.
Yes?
Thermal expansion.
Yes. We have seen thermal stress. We have seen time period of a pendulum. Okay.
For making gold.
Making gold. How? Okay. Let us go and first solve the question. Measurement of length by a metallic scale. Have you ever seen a metallic scale? Do you know what is a scale? Scale or a rule. Scale or rule that you use. Sometimes it's made up of plastic. Even that expands. Sometimes it is made up of a metal. Now, if it is made up of a metal, what will happen is it is calibrated at a set temperature. What do I mean by calibration? If this is your scale, I hope you understand the calibration. It is, let us say, from 0 to 10 centimeters. Then you have 1 centimeter, 2, 3, 4, and 5, and so on. and then you have millimeters. One division on this scale is 1 millimeter. Now, what will happen if you change? Now, this is calibrated at temperature theta naught. So, it will only give you the correct reading at temperature theta naught. Yes or no?
Sir.
But if the temperature changes, so what will happen to this metallic scale? If it is made up of metal specifically, because
It will
metal
increase.
expands more, if it is made up of a metal, it will expand. Now, what will happen if it expands? Will it read
Increase.
less or will it read more?
It read less.
It will read less because the spacing between 1 mm will increase. The spacing between 1 mm or 1 centimeter will increase. Now, if the spacing increases, 1 millimeter does not increase, but the spacing between 1 mm increases, so it will give you a lesser reading. The object will be longer, but you will be getting a shorter reading. Do we understand this?
Yes, sir.
Okay, now in this notes, have you got this notes with you now?
Sir?
Do you have you received this notes that I'm
No, sir.
already sent it to you? Maybe you will get it. Now in these notes, whenever you get it, they have given different cases of different questions that can come on this. I'll not go into all those cases because they may not be of much importance to us. For example, case number 1 is the case when the object only gets expanded and the scale does not get expand. In that case, the only change is the length in the length of the object itself, and you can find out the final length of the object. Yes or no?
Yes, sir.
So this case actually doesn't come in the metallic scale wala case. Yes or no?
Yes.
That is case number 1. If you want, you can keep this in mind. You can write this down as well. This is case number 1, measurement by metallic scale. Case number 1, when the object only expands, the scale does not expand. You can just find the length of the object. The final length of the object will be L naught into 1 plus alpha delta t. We have already seen that. Let us go further. Now, what will be case number 2? Tell me, Gacha, what will be case number 2?
Material is expand.
Yes, the case number 2 would be the measural instrument or the scale expand, but the object does not expand. Do you understand this?
Yes, sir.
Now they have given different variations of this. I have given you different variations of this. I will only give you, what I'll do is I'll give you the actual formula, and it's not here. Okay, I'll write it. So the actual formula, how does the actual formula look like? So you can write the actual formula like this. True reading is equal to scale reading into 1 plus alpha into delta theta. I hope you understand the meaning of these terms.
Yes, sir.
What are the meaning of the terms? True reading means the actual length of the object. Remember, object has not expanded. The actual length of the object will be the scale reading, whatever your scale is reading, into 1 plus alpha into delta theta. Don't get confused. Don't get confused. They have written the formula. They have written the ulta of this formula. What do you mean by ulta of this formula?
Scale read.
They have written the scale reading.
Reading.
So they have written scale reading is equal to true reading
Okay.
divided by 1 plus alpha delta theta hona chahiye tha na? It must be like this, right? It must be like this according to my formula. Yes or no?
Yes, sir.
But they have written in this fashion. Are both the things same? They have written it like this. I am writing it like this. Are both the things same?
Yes, sir.
How? This simply becomes
Binomial expansion.
binomial expansion plus alpha delta theta raised to the power of -1. Just expand this binomially. So you get the same result. Don't have to worry. Both the formulas are same. Am I clear with this?
Yes, sir.
Have you noted it down? Okay. What would be case number 3?
Both are exclusive.
Both are expanding. Now, can you tell me what would be the formula in this case? I'll give you a minute. Think about it and tell me what will be the formula in this case.
True reading is equals to
True reading is equal to
reading.
true reading is equal to
True reading is equals to scale reading into 1 plus alpha coefficient of material minus coefficient of object into delta t theta.
okay. I think the formula you said is correct. The formula will look like this. True reading TR or true measurement TR will be equal to scale reading SR into 1 plus alpha into delta theta. But remember what is alpha here? What is alpha here?
Coefficient of linear expansion of scale.
No. Here alpha is alpha naught minus alpha S. Alpha naught ni alpha O. Alpha O is the coefficient of expansion for the object and alpha S is the coefficient of expansion for the scale. Am I clear with this?
Yes, sir, clear.
So basically, you can use this formula as the general formula. You can use this formula as the general formula. Do you understand this?
Yes, sir.
If you know this formula, you can do all the 3 cases. Case number 1, in case number 1, alpha S becomes 0. Yes or no?
Yes, sir.
In case number 2,
Alpha naught is equal to 0.
okay. So you can use it in both the cases. Yes or no?
Yes, sir.
I hope the formula is correct, or I think it must be. I think it must be. I hope they have written it correctly. Yes. So we understand this.
Yes, sir.
Alpha naught minus alpha S. ठीक है. Okay. What do? We just solve a question based on this, and we would be able to understand the phenomena. So here is the most difficult question that you can encounter in this category. And if you can solve this question, good enough. How does the question look like? A bar measured with a vernier caliper is found to be 180 meters long. That is its original length. The temperature during the measurement is 10 degrees Celsius. What will be the measurement error if the scale of the vernier caliper has been graduated at 20 degrees Celsius? How will you find it out? Will you be able to do this, or shall I do a simpler one first?
Do. Wait, sir.
Shall I do a simpler one? Here what you have to assume that the length of the bar does not change. Do we understand this?
Yes, sir. Sir, explain, sir, once.
Got the answer?
Yes, sir.
Yes or no?
Yes, sir. Yes.
So you just need to put the formula, right? True measurement is scale reading into 1 plus alpha into theta minus theta naught.
Yes, sir.
Just put the values there, and alpha naught is 0. So you get your final answer. Is everyone there on the same page? Do we understand this? Can I have some raised hand that we understand this?
Understand, sir.
Everyone in the class is there? Okay. That was the other part where we were doing uses of thermal expansion. We have seen the third use. Okay, I think we're done. Okay, now up till now we were doing linear expansion. Now let us do a question of areal expansion and lock it up. You remember areal expansion? Everyone remembers it? Only for alpha we have beta, right? And for area we have a naught. And for final area, we have A is equal to A naught into 1 plus alpha delta theta. It's a simple question here. A plain lamina has an area of this. Temperature is 10 degrees Celsius. What is the areal expansion at 100 degree, 110 degrees Celsius? Now, remember, many a times this superficial expansion coefficient is not given. That is, beta is not given. That is, I just want to tell you. Beta is not given, and instead of beta, because for bodies they don't, solid bodies they don't give you beta, they always give you the value of alpha. And that is one thing that you must remember in a question. Invariably in all the questions that you will see for solid bodies, they will never give you beta, they will never give you gamma, they will always give you alpha. So if you have to find areal expansion, you find the value of beta by multiplying 2 with alpha. If you have to find the volume expansion, you multiply it by 3 times. That is how you get the value of beta and gamma. Remember, beta and gamma for solid bodies is not given. Will you remember this?
Yes, sir.
These are the small things that you must remember when you are doing a question, because sometimes in the haste of solving a question quickly, you might do this mistake. So what you got to do here, they have given beta straight away. You just put the value of beta in this equation and you land up with your answer. Yes or no?
Yes, sir.
This is as simple as it gets. Shall we move ahead? The third one is simply what? The third one is simply volume or cubical expansion. We have already seen the formula for this. I don't need to tell you that. I can just go ahead and do a question, and the question in this category can be a different type. So this is one question that is there in our examples, and this is the question that we are going to do. Remember, you only get one chance to read the question, one chance, do it correctly. The volume of a glass vessel is 1000. This is a glass vessel at 20 degrees Celsius. What volume of mercury what volume of mercury should be poured into at this temperature so that the volume of the remaining space does not change with temperature? So they've asked a question in a different way. But whatever way they ask the question, you must understand that all the question would have to be done in similar ways. Do we understand this?
Yes, sir.
The volume of cubical expansion of mercury, obviously mercury is larger and glass is smaller. Remember, see the difference. This is 10 raised to the power minus 4 and this is 10 raised to the power minus 6. Don't make a mistake. These are the simple things that you must remember. Solids expand very, very less, very, very less, very, very less. The question is there in front of you. Let's hope for an answer. They have not asked the question straight away. They've just asked it in a different way. But whatever way they ask the question, you must be able to find an answer. I'll give you a minute. Well, anyone got any answer? Working on it? Shall I help you out or will you be able to do it?
We are doing so.
I'll give you a minute more.
Sir, explain.
Yes? Could you do it?
Explain, sir.
No?
No, sir.
Okay, it's very simple. Nothing complicated. We want the remaining space, the volume of the remaining space should remain same. So we assume that the initial volume of glass vessel is Vg at 20 degrees Celsius. Initial volume that you fill, Vm, at 20 degrees Celsius is Vm, mercury. What is the volume of the remaining space then? Tell me. It will be Vg minus Vm. We agree on this?
Yes, sir.
Now, at an increased temperature, higher temperature, the volume of the glass becomes Vg dash and the volume of mercury becomes Vm dash. Yes or no?
Yes, sir.
The difference in volume is the difference is the remaining space, so that becomes Vg dash minus Vm dash. That must be equal to the original remaining space, Vg minus Vm. Yes or no?
Yes, sir.
That's it. That solves the question. Now you just put the values of Vg dash and Vm dash and you end up with your answer. It's as simple as that. Can you do it now or shall I do it?
Okay, sir. We'll do it.
Do it. So how do you go about doing it? You put the value of Vg dash, which is here. You put the value of Vm dash, which is here. What will happen is Vg on this side and Vg on that side will cancel. Vm on this side and Vm on the other side will also cancel. And at the end of the day, you will be left with this simple equation Vg into gamma, coefficient of expansion of glass, is equal to Vm into gamma of mercury, and from there you can find out the volume of mercury, that is Vm. I hope you have done this question.
Yes, sir.
Pakka? Shall I move ahead with the next thing?
Okay, sir.
And the next thing, there was a question once in an IIT based on this. So I'll just go through this. You might get a theoretical question on this. You might get a numerical question on this. It doesn't matter if you know the principle, you should be able to solve it. What is this thing known as? Oops, where did it go? What is this thing known as? This is known as a bimetallic strip. Have you seen this bimetallic strip? It consists of two metal rods. They are definitely made different because coefficient of expansion are different. Normally one is steel, the other one is brass. They have taken the example of steel and brass. Now what happens? They are of equal lengths but of different materials because we want different coefficient of expansion. The more the difference, the better it is. They are joined together, they become a metallic strip, bimetallic strip, and it can be used as a thermostat to make or break contact. Now when you heat, it will bend. Because why it will bend? Because the expansion coefficients of both the metals are different, so it will bend. And how will it bend? You must understand this. How will it bend? The strip will bend with metal of greater alpha on the outer side. So brass has a greater alpha, therefore brass comes on the outer side and steel comes on the inner side. Do you remember this?
Yes, sir.
It's as simple as that. So it will always bend in such a way that, what? The expansion coefficient higher wala part will be on the outer side, convex side. The other one will be on the concave side. Will you remember this? You want to note it down? You want to note it down? You can note it down. Everything that I say is gold. Gold in the sense anything can come in an examination hall, bacha. And
Right,
that
sir.
time
Okay.
you must be able to recollect what was said in the class. You are lucky that you have this facility. Why should I say? Facility that you can see the lecture again and you can revise the entire class. You can do that as well, but better to use the class once. You may not have enough time left elsewhere. I hope you've written this. Then let us solve this question. See, such questions have come before in an IIT, so they can come again. This is a simple theoretical question because way back in the IITs, when the IITs were very difficult. Now this question can be repeated in JEE Mains. Two metal strip that consist of thermostat must necessarily differ in their what?
Coefficient of linear expansion.
And they must be same in their
Length.
okay. So this is one simple question. As you can see, if I move on to the next one is like this, and it never had a diagram, so I'll not show you a diagram. And here is the question. This is JEE 1999 screening. IIT-JEE has changed its, what should I say, pattern many times in my time. This is not in my time. This is 2 years, 3 years after my time. I was in 1996, 7. A bimetallic strip is formed of two identical strips, one of copper, other of brass. Copper, brass. The coefficient of linear expansion of the two metals are alpha C and alpha B. On heating, the temperature of the strip goes up by delta theta, and the strip bends to form an arc of radius of curvature r. Then r is what? Proportional to delta theta or delta t, inversely proportional to delta theta, proportional to alpha brass minus alpha C. They are assuming that brass ka coefficient is more. It's not given in the question. This you have to understand. Proportional, inversely proportional to alpha B minus alpha C. Which option is correct?
Proportional to delta T.
Pakka?
And inversely proportional to delta T.
Proportional to delta T and
Inversely proportional to delta T. Inversely proportional to alpha B minus alpha C modulus.
how did you get the answer? Have you seen this question before?
Nice, sir.
Huh?
We just assuming.
See, bacha, assumption is a dangerous companion because this companion can give you big bonuses, but many a time it might land you up in soup. But I must congratulate that in this case, your assumption is correct. So your answer is correct here. But how to do this? How to do this? How to get the value of alpha? How to get the value of r? That is my question. Now I've changed the question. I'm not asking you to what it is proportional. I'm asking you, what is the formula? Now, how to get this formula? And this is what you need to remember, which is coming on your screens right now. This is how it is done. And you must remember this because there can be a question which comes in this year based on similar phenomena. What I'll do here is I'll just expand it so that you can see it bigger, and then you remember what is being said or what is being done. And remember, you might not find this question elsewhere, so please be attentive. So this is the diagram. I hope you understand the diagram. There is nothing that I have to tell you in the diagram. Yes or no?
Yes, sir.
Brass strip goes outward because we are assuming that alpha brass is more. Brass is outward. This is what they call as the radius of curvature R. They have taken it till the copper strip. In many questions, in some questions, you might not find it till the copper strip. What they will do in some of the questions is that they will make a center line. This center line is the what's it? Boundary between copper and brass, and then they will call this entire thing as R. Doesn't matter, the question remains same. Do you understand this?
Yes, sir.
In that case, from here to here, the distance becomes d by 2, and from center line to the lower part, it becomes d by 2. Doesn't make any difference. The question remains same. Do we understand this?
Yes, sir.
So I will just rub this off and I'll just, okay. So this is how the question is. I have told you another variation of the question where R is measured from the center line. Now, how do I go? So what you need to know is that this D is the thickness of this entire combination. You have to calculate the value of this theta, or you might be asked to calculate this value R. So these are three things that you will be using: R, the radius of curvature, theta, D, then the change in temperature delta theta, and you will be using the value of alpha B and alpha C. Do we understand this? So these are
Yes,
the terms in this question that you would be using here and there to find out the other terms here and there. There might be also a term of for the length of this entire rod. They have the same length, right? L. So they might also give you this L. Depending on what the question is and what they're asking, they might give you other things. But these are the total quantities that would be given to you. We understand this?
yes, sir.
Now, how do you go about solving this? I'll just go through this. On heating, this will go under linear expansion. We all understand this. L0 is the original length. Yes or no?
Yes, sir.
So length of the brass, please keep on noting, drawing the diagram and keeping on it. Length of brass becomes L0 into 1 plus alpha into something. And length of copper becomes this thing. We understand this.
Yes, sir.
From the figure, arc and the length of the arc, we can find out the length of the arc B is length of the rod B when it is expanded. Remember, when it is expanded. So it is R plus D into theta, yes or no?
Yes.
Length of copper rod is R into theta, yes or no?
Yes, sir.
Angle is arc by radius. You divide the two quantities, and this is the most important result in the entire discussion. R plus D by R is 1 plus ऊपर वाला convex side
By
divided by 1 plus alpha into नीचे वाला convex side. You understand this?
yes, sir.
If you remember this, then this entire thing here is just binomial expansion and nothing else. Do we understand this?
Oh, yes, sir.
So draw the diagram, write these fundamental equations, and then you would be ready. And this is how you find the value of R by binomial expansion. Write these fundamental equation. Which equation you will write? Equation number 1, equation number 2, equation number 3, equation number 4. That leads us to equation number 5, and that leads to this equation, equation number 6, and that's it. And you draw this diagram, you would be able to find out anything that comes in this metallic strip wala question. Do we understand this?
Yes, sir.
Please note it down.
Wait, sir. We will not take it. Completed, sir. Sir, completed.
Okay. Let us solve one or two more questions, and the next question is this. An iron tire is to be fitted on a wooden wheel 1 meter in diameter. Just tell me how it is to be done. The diameter of the tire is 6 mm smaller than that of the wheel. The tire must be heated so that its temperature increases by a minimum of what? Wooden wheel, iron tire. I'll give you a minute to think about it. You must remember, beta, the questions on thermal expansions are very less. Whatever questions are there, that will cover the entire topic. Any idea how will you do this, bacha? See, such questions, if you do a simple mistake and if you just don't understand one point, you might end up in a soup. So how are you going to do this? The diameter, you just have to understand the question. Wooden wheel is 1 meter in diameter. We all understand this. The diameter of the tire is 6 mm smaller. So tire must be heated. Yes or no?
Yes, sir. Yes, sir.
Initial diameter of the tire will be 994 mm. It's very simple to understand this. From there, you can find out the radius. Simple. Yes or no?
Yes, sir.
Change in the diameter has to be 6 mm. So change in the radius has to be 3 mm.
3 mm.
But you don't have to change the radius. You have to change the circumference. Do we understand this?
Yes, sir.
That's it. The change in length will be y into alpha into delta theta. Yes or no?
Yes, sir.
Here, volume expansion is given. So you find out alpha. Yes or no?
Yes, sir.
You put the values and you stay happy. So change in length delta L will be equal to 2 pi into delta R. Yes or no?
Yes, sir.
Ting, ting, ting. Do you understand? Ting, ting, ting.
समझ में आया, sir.
Then this ting, ting, ting goes here. Ting, ting, ting.
Ting
And
comes
you have your answer.
500 degrees Celsius.
That is how you do it. Am I clear?
Yes, sir.
Any doubt? Please raise your hands.
नहीं, sir.
Pakka?
पक्का.
So jate jate, the last one in this category and the last one in this category. I don't know whether you know it or not, but this is what I call mixing of two topics in one topic, and these are very common questions in JEE Advanced. During my time in JEE, JEE used to be very tough. It is tougher now. I don't know. The only question that we were scared of is where two topics used to get mixed and everything goes to go. Here, two topics are getting mixed. Let us see. A wire of length L0 is supplied heat. Okay, the definition is not, language is not good. Is supplied heat to raise the temperature by T. If gamma is the coefficient of volume expansion of the wire and y is the Young model of the wire, then the average density stored in the wire. Obviously, they have not said that the wire is clamped from two sides. The wire is clamped. What is the energy density stored in the wire? It is clamped. Understand this? Will you be able to do this?
Sir, wait, sir, we'll try.
Try, and that would be the last question for today's class. I'll give you a minute to think about it. So how do you do this? It is not mentioned that the wire is clamped. What the wire is clamped. Have you heard this term energy density?
नहीं आ रहा sir.
Have you heard the term energy density?
Yes, sir.
Yes. Then you can be. It is very simple. We also know we have seen thermal strain. Do you remember thermal strain? Alpha, delta, theta.
Yes, sir.
That's it.
Alpha, beta, delta.
Energy is half into stress
Stress
into
into
strain.
strain.
You find out stress, you find out strain, and you're done. Or you can write it as half y into strain square. You know this, right?
Yes, sir.
That's your answer. But that's it. You get this?
Okay,
So this
sir.
answer could be asked in a different way. It can be a multiple choice question. So the strain depends on what? It will give you y, alpha, theta, all these things. It becomes a multiple choice question. It becomes a question of JEE Advanced in multiple choice. If you know how to do this, it's a 1 minute question. Yes or no? These are
Yes,
the
sir.
type of question that come normally, beta, whether it's like mains or advanced. Question has to be done in the time that is given to you. If you can't do it in that time, it is of no use. Yes or no?
Yes, sir.
So then I think expansion for solids is done in this class, and in the next class we'll move on to expansion of what? Expansion is not over. We'll move on to expansion of liquids, and obviously I'll give you the pointers about expansion of gases, which may not be a part of the curriculum, but if it comes, you will be at the edge with other students. So that's it from my end for today. I hope you liked the class. If there's anything that I can help you with, I'm always there. Feel free to ask your doubts. For now, it's a wrap from my end. See you tomorrow in the next class. Take care. Bye bye.
Okay, sir. Bye.